You are welcome to class. Today we are going to be taking sword. Sword. So what do we mean by sword? Sword come to play when we have the square root of numbers and we cannot really get their perfect square. Square root of numbers that does not have a perfect square. So how do we calculate them? So we make use of sword. On adventure, we have some numbers that we have to find their square root, as I've said earlier, and we cannot easily get their square root. So we can easily simplify those numbers and leave them with their square root. So such are form are called sword. Let's take for instance, we have root p. And of course, we know p is not a number and we cannot calculate its square root. So because we cannot calculate its square root, we leave it as root p. So this is example of a sword. So in short, as a basic introduction, we said when you are finding the square root of a number that does not have a perfect square, so we can equally simplify it and leave it in the root form. So we have that to be called sword. Now let's see another example. We can have square root of 2. Of course, we know the square root of 2 is going to give us decimal. So because of that, we don't want an answer to be in decimal point or to be in fraction. We can equally leave it like this. So we leaving it like this, we are saying this is a sword form of square root of 2. So we call this root 2. We call this root 2 under sword. Now, of course, when we talk of root 4, of course we know 4 has a square root. So this is telling us that we have the square root of 2 multiplied by 2. So of course the square root of 4 will be what? Will be 2. So this is how to simplify sword. So this one now that doesn't have a perfect square, we leave it like this. This one now, root 2 is in its simplified form. While 4, when we find the square root of 4, it's going to give us 2. So that's similar sword. Yes, before we continue, I want to explain when you say something is a number is irrational. When we say a number is irrational, it's another term that can be used to represent sword. When you say a number is irrational, that means number. Sorry. When you say a number is irrational, that is the number has a square root. Square root of 2. So this is an irrational number. Square root of 2 is an irrational number. So when we say a number is irrational, that means it has a square. So you can't get their perfect square. So when you're looking for their square root, sorry, they have square roots. You can't get their perfect square. So that is why you call them irrational number. Now, we call some sets of sword similar sword. Now, when we have swords with the same irrational number, when you have two types of swords, and the two types of swords, when you have two different swords, sorry, and the two swords have the same irrational number, so such sword is called similar sword. When you have two swords with the same irrational number, we call that sword similar sword. Let's see example number 1, root n and 5 root n. And when you look at this, you will see that the irrational number in the first sword is root n. Also, the irrational number in the second sword is root n. So these two swords now are said to be similar sword. They are said to be similar sword because they both have n and n as their irrational number. Good. Now when you look at the second one as well, it is also said to be a similar sword because both sword has x as their irrational number. So it's root x equal to root x. So that is a similar sort. Likewise, when you look at the third one, it's also a similar sort because they both have root 2 as they both have 2 as their rational number. So you have root 2 will give you root 2. So when you look at the third one as well, the same thing applicable to them. Never forget, we are considering what is inside our square root, the number that we have inside our square root. If the number inside the square root are the same, then we call that type of sort a similar sort. Now this is what we are saying, root y and root y. So root y is equal to root y. So now when you look at this number 3, you see that this one is root 3, this one is root 2. So these sorts are not similar. I hope you understand what we are doing now. Now, root 3 and root 2, they have 2 different irrational numbers. When you see this sort and this sort, they are 2 different sorts because the root, the number, the irrational number are not the same. So this is what this one implies. This one means that root 2 is not equal to root 3 is not equal to root 2. Same thing applicable to the last one. This is root A and this is root C. So root A is not equal to root C. So the last 2 examples are not similar sort, while the first 4 examples are similar sort. So there are possibilities of having these different sorts. For example, or for calculation. So when we have similar sorts, there are ways to approach them. Then when we have 2 sorts that are not similar, there are ways to. Now, having understand similar sort, so the next thing that we're going to look is the simplification of sort. We can simplify sort. So what does simplification of sort mean? It means when you have a bigger irrational number, we have a bigger irrational number, so we want to make it become smaller. Like you have, for example, say you have root 45. When you look at this root 45, it can become smaller. When you have root 98, root 8, then root 60. So these are bigger forms of sort. Our attempts to make them become smaller is called simplification of sort. So let's quickly see the examples that we have. We have them on the board. Number 1, simplify the following sorts: A, B, C, and D. Number 2 is express the following as a single sort: A, B, C, and D. So let's quickly solve. Number 1, root 45. Now, how do we simplify root 45? What do we do to make this root 45 simplified? So the very first thing that we are going to do is that to make it easy for ourselves, let's use if you still remember how to find the product of a prime number, in your basic class mathematics. So that's what I think I would suggest you use, so that it can be faster for you to solve that. So let's quickly see how root 45. What we do is to simplify this root 45. And the question is, how do we simplify root 45? It's very simple. We can use products, what do we call it? Prime number, product of prime numbers to solve that. And how do you do that? Say you have your 45. What are the numbers that can divide this? Prime numbers that can divide this. Of course, you have 5. This means 9. You have 3. It means 3. Then 3. It means 1. So, now you express this. Listen. When you look at this, you know this is 3 times 3. This is 3 times 3 is 9. So it means you have 9 multiplied by 5. 9 multiplied by 5 will give us 45. Good. Since we have that, this 9 has a perfect square. And so because 9 has a perfect square, you write it first. Because 9 has a perfect square, you write it first. Alright, this is what I mean by that. I'll give us root 9 times 5. And we can split this to be, now we can split this to be root 9 times root 5. So what's the square root of 9? We know this will be what? Square root of 9 is 3 times root 5. So 3 times root 5 will give us 3 root 5. Now you ask, look at this now. We've been able to simplify that root 45 to 3 root 5. You only have 5 as a rational number. It's not as big as 45. I hope you understand that. Very good. And let's take the second example. Example B says you have root 98. The second one we said is root 98. Now when we have root 98, let's use our usual procedure that we used in the first one. So you have 98 divided by, of course you know we can use 2. 2 in 9, it gives us 4, remaining 1 in 18, 9. So 7 can go to give us 7, and 7 divided by 7 will give us what? So of course you know this is 7 times 7 to give you 49. So don't forget that I did this one. You first of all have root 49 times 2. That will give us root 49 times root 2. So you have root 49 squared give us 7. 10 times root 2 as 7 root 2. You can see that the rational number has become simplified. It's now small, while this one is bigger. That is why we call it simplification of sum. So let's do the number 3. Number 3, root 8. Of course, we all know that 8, 2 is 4, a bit 2, 2, 2, 1. Now when you have this 2 times 2 times 2, just pick these to match them together. Then it means 1. Root 4 times 2. That gives us root 2, root 4 times root 2. So the square root of 4 is 2 root 2. I hope you understand that. Okay, let's quickly go to the last one in that question 1. Root 60. Root 60 will give us. Now let's split it and see. 60 you have 2, you have 30, you have 2, you have 15. 15. You have 15 does not have, you can't get any perfect square from 15 again. So, okay, you have 3 here, 5, you have 5, 1. So when you see, what we just need is number that have a perfect square. If you understand all the ones we've been doing, we have been picking the ones with perfect square. Look at the very first example. We picked 9 times 5. If you remember when we were doing it, we picked 9 times 5. Now for the second one, we picked 49. We added these two together. We picked 49 and the remaining 2, we write it. We did not pick 7 and this, 7 and 2 because the answer will not give us a perfect square. When you multiply 7 and 2, you have 14. That will not give you a perfect square, so we are not picking them. So we are picking two numbers that are the same, so that by the time you find the square root, it gives us one of the two numbers. Do we get that? Very good. Now that is why we have this. So when you come here, we have 2 and 2, they are the same. So you multiply the 2 together, so they can give us a perfect square. So the 2 now will give us 4 times the 2 that is remaining that we cannot get a perfect square from. Multiply the 2 together. It gives us 15. I hope you understand that now. You don't just pick any numbers. You pick numbers that are the same. so that by the time you multiply their answers, the answer will give you a perfect square, which is one of the two numbers. And this is what we said now. This now will give us the square root of 4 times the square root of 15. By the time you find the square root of 4, it will give you 2. So your answer now will be 2 root 15. Now I hope you understand that. Please, if you have any question or there is any of the explanation that you are not clear with, don't forget we have told you that our responsibility is to ensure that mathematics becomes simple, no magic, and clear and straightforward. So if you have any question, do not hesitate to use the comment button. Alright, let's quickly solve the number 2 question before we call it a day. A, 2 root 5. 2 root 5. So, what they're expecting us to do here is that we have to express this expression now. We have to make it a single sort like this. We have to make it a single sort like this. So what do we do? This one simply means any number that is outside the root means we have found the square root already. So you return this one back to the square root to the root. To return it is going to be square root of 2 squared. That is 2 times 2 times the square root of 5. So that will be 2 times 2 give us 4 times root 5. So that will be what? Root 4 times root 5 root 20. Is that clear? Very good. So the B now is 10 root 2. It's the same thing as you do this. This number that is outside the root, you multiply by itself. That will give us square root of 10 times 10 times the root 2 as remaining. So 10 times 10 is 100 times 2. So that will give us what? Root 200. Now let's see the third one. The third one is 2 root 10. Now don't forget, as we've been doing, the one outside the root, you multiply by itself so that it can be inside the root. That will be square root of 2 multiplied by 2, it's going to be inside the root. Then multiply by root of 10. So this will give us 2 times 2, 4 times root 10. So root 4 times root 10 will give us root 40. Then the last one is there. Is 4 root 11. 4 root 11. So this will be, you see, remember, multiply this one outside the root 2 times. That will be 4 times 4 multiplied by root of 11. So that will be 4 times 4, 16, root of 16 multiplied by root of 11. Of course, that will give us 16 times 11. This is 6, this is 1, this is 6, this is 1. That will be 166. So our answer is going to be the square root of 166. Now, so far so good. We've been able to solve, been able to see introduction to sort. What does sort means? When do we use sort? And we've been able to talk about similar sort and simplification of sort. I think in our next video we are going to take addition, subtraction, and properly multiplication of sort. So before we go, I would like to give us some practice questions that we can lay our hands upon so that we can test our knowledge in what we have been studying so far under sort. Now let's go and try lay our hands on these 2 practice questions. Let's lay hand on them and solve them. Why it becomes very important for us to do practice question is for us to be able to see if we really understand what has been taught so far. Of course, you know that we are going to solve it probably in the next video, but please, you will do yourself a very good help if you can solve it before you proceed to the tutorial where we have the solution to the practice question. Then you can be able to figure out where your mistakes are, and you can be able to pick out answers, figure out your mistakes, and you can be able to see the correct way to go about it. Once more, please and please make sure that you lay your hand on these practice questions before you go to the solution video. That will help you a lot. Thank you very much. Before we go, never forget that men will always continue to strive if you will never acknowledge the place of men will always continue to strive if you did not consider God. Removing God from the equation of your life will do you a lot of harm, because you continue to strive. Because God is the God of all possibilities, and with Him all things are possible. Thank you very much.